All right, to take up where we ended off, part E, we collect the data on the students and then record pass and fail. Not the number that they pass out of 4, but just whether they pass or fail. What type of variable is G? And we've talked about this a number of times. If you're putting a label on that, you're not measuring or counting, that's going to be a qualitative. And pass and fail don't really have an order, so let me further say that this is nominal. Just a label, just a name, nom. Can G be a random variable? No. Why not? Random variables, it's not V-A-R, random V, because has to be quantitative. A number, well, a value that comes from a measure or count. Quantitative. So it can't just be a number. It can't be a zip code or a label that you've assigned a subject in a treatment group, like your subject number 0, your subject number 1, because you have to have measured or counted. Now we're going to look at the data we collect from the student. We've got pass or fail and record for each quiz the number of quizzes that they pass out of 4 quizzes. So a student could pass none, could pass 1 out of the 4, could pass 2, 3, or they could pass all 4. This is a quantitative variable, not qualitative, it's quantitative. Can it be a random variable? Yes. It's quantitative, and the value is the result of a random event. All right, so a random variable has to assume a numerical value that happens by chance. Now I've got a probability distribution here, and I've put it as a row instead of a column. This is going to be the values of y, and then this will be the probability of y equaling the different numbers. Y could be 0 passes out of 4, 1 pass, 2, 3, or 4. And I completed 2 of the entries for you in the probability model, probability distribution. Remember how I wanted to record those certain values? For instance, the probability that we passed 0, and that was 0.036. Let me check. Is that what I got? Yep, 0.036. Because I wanted to use it later. Now you didn't know that because you didn't make out the test. And then, probability that all 4 pass. That's going to be the next easiest. I pointed that out on a tree. Pass all 4. I pass the first and the second and the third and the fourth. So that's 0.7 multiplied by itself 4 times. In other words, this is going to be 0.7 multiplied by itself 4 times, or I'll raise that to the 4th power just to get a decimal. 0.7, then raise that to the 4th power. Does that even look right? No. 0.7, so I'm going to sneak because I can't see. And then raise it, where's my caret? To the 4th power. 0.2401. So this guy as a decimal is 0.2401. Remember, the sum of all the probabilities has to equal 1. So let me just figure out what my missing value is. Oh, the probability is exactly 1. That was actually an answer to the first question. We said the probability of exactly 1 was 0.132. I don't even have to subtract the sum of the remaining cells from 1. This should be 0.132. I'm just going to check. So I've written in the first cell probability of 0 passes 0.036 plus 1 pass was 0.132 plus I gave you 0.2604 for probability of passing exactly 2, probability of passing exactly 3, and probability of passing 0.24, so 0.2401. Let's just check this, and it equals 1. Do a little happy dance.